This is problem 85 of Neetcode 150, Pacific Atlantic water flow. So we are going to be given a rectangular Iceland height, where a height at a particular row and at a particular column is going to represent the height above the sea level of the cell at this coordinate. So I will actually jump right into this image because the explanation itself is a bit overcomplicating the problem. So let's take a look at this, okay? We can see that we have a grid, right? And we have numbers in a grid. We can see that to the left of this grid, we have what we see as the Pacific, which is representing an ocean. And to the right, we have another ocean called Atlantic Ocean. All right, and to the top, we have the Pacific again, and on the bottom, we have Atlantic again. So here's the thing, okay? So if you start at a cell, so let's say that I pick 6 here, okay? The middle cell. Basically, I can only move to the right, to the left, to the up, and down. I can go diagonally, all right? So this is important, and I can only move if basically my neighbor's cell has a value that is less than my current value. Otherwise, I am blocked. So here at the 6, if I go up, oh, I have a 7. Can I move up where I have a 7? No. So I'm stuck here. If I go to the right, can I go right here? Yeah, of course, right? So this is something I can do. Can I go to the left? Yes, because 4 is less than 6. And can I go down? Yes. Okay. And you can see that when I move to the right, because when I say that I start at 6, I'm not referring to a single person that only moves in one direction. I'm speaking about like a flow of water that flows to the left, to the right, bottom, won't flow on the top because it's greater value, but still. So it will simultaneously go right, left, and bottom. And at these stages, it can only go to the place where basically the value of the cell is less than its own value. So it can, so at the 4, the flow of the water can keep flowing up, cannot flow right. Well, obviously can go to the left because this is where we came from. Can go bottom, right? 3 is less than 4. All right, and if we take that value 5, well, we can go to the left, we can go to the right, but actually we are on an edge case, right? Because we reach the Atlantic, so that's cool. So we reach the Atlantic. um, that's okay. But the problem states that we want to find the cells that can reach the Pacific and the Atlantic. So we have one. So starting from the 6, we can definitely reach the Atlantic. Can we reach the Pacific? That's the thing. But you you can probably see here that yes, we can, because we can go to the 4 and then to the 2 and then Pacific, and then we can actually reach the Atlantic. So there's like a nice flow here that will allow us from the 6 to go both Pacific and Atlantic. So to solve this problem, we could potentially use breadth first search or depth first search. Speaking of depth first search, which is the technique I will use in this video, um, well, if I start at 4 and I go see all my neighbors until we reach well, until we find a path, and then I go to 2 until I find another path, and then I go to 7. Well, see, I will go through many rows simultaneously. Like I will first go at 4, then I will go at 2, then I will go at 4 again. But by doing this every time, I will eventually come back to this 4, and it will be quite repetitive. So the first thing that we want to do, it's basically it's to use what we know. So what we know is that all the values to the left are actually accessible to the Pacific. Same for all the values at the top. All the values at the bottom can actually go to the Atlantic, and all the values to the right can go to the Atlantic. And the edge corner is here, so bottom left and top right can actually access both directly. So we're gonna add these to basically to the the values. So we are gonna go use depth first search for each of these values. And what we want to check is the next value. So the value that is next to me, is this well, is this greater? Because if the value is because starting from, let's say 7, um, or let's say starting from the 3 here, well, if the value 4 is greater, um, well, it means that we can actually go uh, to this value 4, because we're doing like a sort of back engineering, right? Because the problem itself states that we're starting from any cells and we want to go to an edge where all the values on that path to the edge are decrementing monotonically. But when we start from a side, we want actually the value to increase. So we're going to use this type of depth first search to solve this problem. Okay, so let's go ahead and solve this. So the first thing that we want to do is to keep track of the length of the rows. So I will create a variable called rows and another variable called columns. And rows is basically going to be equal to the length of the heights. So the columns will be equal to the length of the heights at any index. So I will say at index 0 first. All right. And I will also create a set where I keep the coordinates of all the values that can actually access both oceans. So at the end, I will have my for loop where I will check for each single columns. Is this value seen in the set of Pacific and the set Atlantic? If it is the case, I will return I will return this to the solution, because at the end we want to return like all the cases that can access both Pacific and Atlantic. So what I will do is I will create a set for Pacific and Atlantic, and I will create my set for both. All right, great. So I will also create my depth first search function, because that's the basically the core of the solution. And inside my depth first search function, I want to pass uh, the coordinates. So I will say row and columns. I also want to make sure that I keep track of the previous height that I visited, so I can apply my logic to it. And I also want to make sure that the value is not invisited. So we don't do some ping pong between two values, right? Because if I go to like if I have two values that are exactly the same values, where, well, technically, according to the problem, you can float this case. So if we have two trees next to each others and we don't keep track of a set of the values we've seen so far, well, we might just gonna do some ping pong between these three these three values. So let me call this visit, and I will also have this. I will call previous height. Okay, so inside this depth first search, we are initially gonna have all our if statements, and these if statements will be what will make us do our return statement. And otherwise, we are gonna add to visit. We're gonna add to this the current coordinates. So we're gonna have the tuple, row, and columns, and then we're gonna go visit the all the other solutions. So I'll have my depth first search row, column. I will set the visit to what the visit is after we added this coordinate in it. And I will also make sure that the height is set to the current height. So add this row and add this column. Great. And I will do basically this for all the possible cases. Okay, so what are the possible cases? basically I can go to the left, I can go to the right, I can go up, and I can go down. So we will do exactly this. All right, so first thing, we can move our row by one. So we're gonna go down by doing so. We are gonna also move our row up. So by decrementing one, we're gonna go up. We can go to the right, and we're gonna do this basically by moving or incrementing our column by one, and we can decrement our column by one to go to the left. Right, okay, so this is the logic of the depth first search function, and we still have to actually ensure that we handle the cases here. So what are the cases? Well, first thing I can think of is make sure that our value or the case, so at this column, because we know that since we're just like blindly using depth first search on all the neighbors, and let's say we start from the value 6 here. Well, the first search call, it's gonna actually call the 4, the 7, the other 4, and the 5, right? And at this 4, well, we are also gonna call all the neighbors. So we know we're gonna call back this 6. So we want to ensure that we are not just gonna call this like headlessly and take a lot of like a huge time complexity. So we're just gonna say that we want to return if that this coordinate is in visit. All right. So what else? We want to ensure that we are in bounds. So we know that R and C represents the index of the row and the columns. So if we have a negative index at either the row or the column, which it can be found by using the minimum value between the row and column. So if any of those is actually smaller than it's actually smaller than 0, this is a time where we want to return. Another thing is, what if the row is too big, right? So if row ever appears to be exactly the same length of rows, or again, if the column is exactly the same length of calls. All right, so these are big questions you wanna ask. There's another one, of course, because there's this concept of we can only flow to a case that whose value is less. All right, so what I will do, it's basically I will ask if the current height is less than the previous height, and if it is, I will return. So if the height at the coordinate that we have, so at this row and at this column, if this is if this is smaller than the previous height that we just passed in here, so this is another case where I'm gonna be willing to return. Okay, right, so these are all the cases. Now we have our depth first search function ready to be used, and what we're gonna do, it's basically we're gonna start from the Pacific and from the Atlantic. So let's just actually use the hedge column. So we're gonna go for C in the range of calls. All right, and what I will do, it's basically I will use two depth first search call. All right, and the first one, well, at which row do we want it to be? Well, we want to take the top row. So the top row is going to be at the index 0, and this is going to stay at index 0, non-negotiable, because we want to start for all the values that are like next to the Pacific Oceans. And for the second call, we want to take like the bottom row. So we're going to just say rows -1. This will give us the index of the last row. All right. In terms of columns, they are free to move because we want to go for every single column in these two rows, right? And now the third value is basically the visit set. In our case, actually, the visit set on the top is going to be the Pacific Ocean, right? So we're going to pass the Pacific Ocean, which is a set we created earlier on, and a previous height. Well, it's basically just going to be the height at the index 0, right? Because the first call never goes on another row than the first row. All right, for the second depth first search call, we are using the last row, which is next to the Atlantic Ocean. So instead of passing the Pacific set, we're gonna pass the Atlantic. So ATL, and the height is basically gonna be at the index of the rows -1, and the columns are free to change as well. Okay, so this is good. We're gonna do pretty much the same thing, but now we're gonna do this for the edge columns. So I will say, well, for each edge columns, we're gonna go for every single row. So I will say for R in the range of rows, right? I will also create my 2 depth first search call, and this time the row is gonna be free to change for both. The thing that will be set is the column. So initially on the first call, I will use the first column, which is going to be at the index 0. And for the second call, I will use the top right column, which is going to be equal to the index of the columns -1. All right. So the column with the index 0, it's next to the Pacific, so it makes sense that we pass to it. And the right index is going to be next to the Atlantic, so we're going to pass ATL to it, right? And now we're going to have to pass both heights. So for the first one, we're going to use basically, well, the row is going to be changing, so we're just going to pass R, but the column is going to be always the first one. And for the second call, we're going to use a changing row, but the column will be calls -1. All right, so this is good. Now we created basically all our depth first search call, and we're going to go for every single values that are next to it. And we are, if we ever appears to find a if basically there's a coordinate that access to both the Pacific and the Atlantic. Now we want to return this, so I will create first a result list, and I will say basically for R in the range of rows and for C in the range of columns. So we're going to go see every single case. So for R in range of rows, and for C in range calls. All right, so if that particular coordinates at this row and this column is in the Pacific, and also in the Atlantic. So if it is in both, I will add this to the results, and we want to return basically a list of lists. So we'll return a list with the row and the columns, and then we can return the results. So if I didn't mess up, this code should work perfectly fine. And let's test this out. And we have an error. So Pacific is not. So I did an error here. Oh. All right, let's test this again. And there you go. Awesome. So I hope you learned from this video, and I hope to see you in the next one.